Here we're looking at a little sneak peek at a new upcoming development which follows on from the existing LUT point manipulation. So in this case we've got a profile which is a JOLED ASUS, and at the moment we're targeting Rec 709, as you can see within the native gamut of the display. And we can see there's a couple of points that seem to be kind of outside, but interestingly are showing a relatively low delta E to Rec 709. But if we look at the extracted color space of this display, it just helps us to spot not just those few outliers we could see anyway, but any errors inside the volumetric space of the display. Obviously, if we select a point, we get our pop-up little window here with the XY information, as well as within the floating point info window. If we turn on the tangents, then we can obviously see where the patch says it should be and where the measured color is. And obviously, with it being a low value, in this case we are looking at a patch that is 025 across the board, which means it's a relatively low light patch. It means that the patch may or may not be an incorrect reading. What we would do is quickly look into another graph, so let's say RGB balance, and we can see that the patch is that one there. And yes, actually the display is moving in that direction, so as it gets closer to black there is certainly a bit of a color shift to it. So I would say that that point and that point are actually correct, but black is significantly wrong. We'll come back to black, but for now we can go back into our graph, because we know that we have some points that are outside the actual native gamut, which is not possible. So we know that that point is wrong, and again it's a very low value, it's a low green. But of course we know that it should be basically near 100% green saturated, because we are targeting the native color space of the display. We extracted a color space. So what we can do now is just move that point so that it is closer to where it should be. And then once we've got it into a rough location that we're happy with, we can apply. Now the yellow line tells us where the point has come from, and the fact it's a larger grey blob, not a coloured blob, means it has been adjusted. And the reason for that is that if I want to, I could go and look at another one. Here we go, see that one here, which in this instance is a cyan of the same low value, and of course you can see from that that it's significantly a long way from cyan. So again, the fact that it's outside the native gamut of the display means it has to be an error value. So we could quite simply pull that back in and put it into a more logical location. The reason for doing this is that it's just correcting inaccurate probe readings, which means that the LUT generation will be more accurate, because there won't be invalid data being used with the profile. So again, just putting it there roughly. But you can see now that I've moved that point. If you look up here, we've got the other point that we moved is there and is also dark grey. If I click that, you can see that it hasn't been applied yet. Right, so once I've adjusted the points, we can apply. We can go down to our one that we moved near the cyan. There we go. And again, we can see it and we can apply. And then we can save that profile as a new profile with those adjustments made. Neat.